Now let us start a crucial topic that is called remainder theorem. You know the division algorithm, that dividend equal to divisor into quotient plus remainder. Here in the polynomial also you are going to divide the polynomial that you have learnt in your 8th standard also. We repeat also this thing, and now we add something new idea and new topic, new technique, new method also. So what is remainder theorem? If a polynomial p of x p of x having degree greater than or equal to 1, degree is maybe equal to 1 means maybe linear polynomial, or greater than 1 means linear or quadratic or cubic, etc. Biquadratic maybe. So if a polynomial having degree greater than or equal to 1 is divided by a linear factor x minus a, suppose linear factor maybe x plus a, etc. So if it is divided by linear factor x minus a, then the remainder is p of a. Try to understand this, because remaining exercises are depend on it. So please be alert. One polynomial is given. Maybe it is linear or quadratic or cubic or biquadratic. Is it okay? Now if this polynomial is divided by another linear polynomial or a factor, then the remainder is this. It means what? If it is divided by x minus a, see here it is a, here it is also a, here it is minus, here it is plus. So as for example, you can say if a polynomial p of x is given, suppose x square minus x plus 1, if this polynomial is divided by another polynomial, suppose g of x equals to x minus 1, then the remainder is what? No need to divide this. Means no need to applying long division like this. Don't do this. Okay, this is also one of the method. But here in 9th standard, without doing this long division method, we can find by applying this remainder theorem. So if there is a minus 1, the remainder will be p of 1, minus 1 will be plus 1, minus a will be plus a, like this. So place this x means 1, 1 square minus 1 plus 1, 1 square is 1 minus 1 plus 1, 1 minus 1 0, plus 1 is 1. Okay, if you apply long division also, then you can find the remainder 1. See, in this way, x should be multiplied by what to get x square? X should be multiplied by x, x into x, x square, plus minus minus, x ones are x. Okay, now change the sign, minus and plus. Plus x square minus x square will be 0, plus x minus x will be 0. Now bring down 1, this is your remainder. This is remainder r of x. So in this way, this method that you have learnt in 8th standard, and now there is a remainder method. So if it is divided by x minus 1, then remainder is plus 1. If it is divided by x plus 2, then remainder r of x equals to what? Remainder is plus 2 changed to minus 2, r of minus 2. If it is divided by x minus 3, then remainder will be minus 3 will be plus 3. If it is divided by 2x minus 1, then remainder is not 1. See, here coefficient is 1, here coefficient is 1, but here coefficient is 2. So you have to write like this. Remainder is minus change to plus 1, but 1 divided by 2. Here also we do like this. Minus 3 change to plus 3. 3 divided by 1, but 3 divided by 1 means 3. Not necessary to write 1 in the denominator. But here coefficient is there. So you have to write remainder like this. Minus 1 upon 2. If it is divided by 5x plus 3, then remainder will be what? Plus change to minus 3 upon 5. Okay? Remember one thing also, factor theorem. If a polynomial is given and a polynomial is divided by another linear factor like x minus a, and then if you find the remainder, if the remainder is 0, then x minus a is called factor of the given polynomial. Means for the given polynomial, if it is exactly divisible divided by another linear polynomial, then x minus a is called factor of p of x and vice versa. It means what? If remainder is 0, suppose r of 2 is 0, we said x minus 2 is a factor. Suppose it is given that x minus 2 is a factor, then consider that, accept that r of 2 equals to 0, means remainder 0. If r of minus 3 equals to 0, we said x plus 3 is a factor. And if it is given that x plus 3 is a factor, we said that r of minus 3 is 0. Means remainder is 0, then a factor, factor, then a remainder. Okay? We will concentrate it on this laws. These laws are very important, and you can understand this law by applying numericals. That means when we start our exercise, then we understand it very well. Okay, one by one. We will do both method, long division method also, remainder method also, for your concern. Okay, so write down this. After that, we will start your exercise 2.3, which is on page number 40 in your textbook.